In last video, we understood resilient distributed dataset, one of the pioneer feature of storing huge amount of data in Apache Spark. Moving to next, today we are going to understand what are data frames. Data frames are the default data types in Databricks, basically in Apache Spark. In this, we are going to understand how to build data frame from CSV, JSON, Parquet, and how to inspect schemas. Think of data frame as a polished version of RDD. Think of data frame as a polished version of RDD. They look and feel like Pandas data frame, but scale like Spark. They carry not just data, but also schema information, columns, names, and data type. That schema unlocks Spark Optimizer, letting it to figure out the best way to run the queries. So earlier, RDDs were just the bag of objects. Data type was not known, but here, since Spark from the initial part itself knows the data type column, so therefore the optimizer within triggers in, and it will figure out the best way to store and process the data. Let us understand what is a data frame. A data frame is a distributed collection of rows with a known schema. Whenever I say a word data frame, consider it to be like RDD plus schema. Always consider that this is RDD plus schema. Every row is like a Python dictionary or a database record. If RDD is just a bag of objects, data frame is a table with structure. Columns have names and data types. Spark can reason about queries because it knows the schema. You can use both APIs, select, filter, and SQL on the data frame. You can use both the types. And see, there is a way of converting everything into declarative. So RDD, you have to do a lot of small operation and manage those states and all, correct? The data frame came something on top of RDDs, where the syntax was declarative, something similar to pandas, but internal working is completely different. Internally, uh, optimizer would pick in or trigger in and would scale the data frame on multiple cluster. It would manage it, the data transfer, any operations by itself. So that's the power of data frame, and it's a default data type as already mentioned. Now let us create a simple data frame. Uh, so let us run this code. In this code, what we are trying is we have created something called Spark session, and from Spark session, we are just taking one data set or Python list, and we are going to simply convert that list into a data frame. Let us run this. Once we run this, we could very easily see a df object is created. Df is data frame. If we expand, you would see that it has two columns. One is region, which is a string, and a revenue, which is a long. The data frame, as you can see, representatively is looking like a table or a day, and each record is a database record. Okay. There are multiple operations which are possible with data frame. One of that is print schema. You can just do a df.print schema, and you could understand what is the content within the data frame. You can do a describe.shows, which tells what type of object is present in it. Like for example, you can see a summary that there is a string region and string revenue present within. You can do the way Python pandas video. You must check my Python series and Python playlist, and within that playlist there are extensive videos created for Python pandas. In that I have shown the different functions that are possible. Almost similar functions are possible with data frame. So you can do df.head, df.tail, you can do df.show, you can do multiple things with data frame. Let us try something like df.tail. Df.tail will give, since our data frame is extremely small, it will give the same records, but you can do that. Even you can put like just last one record, right? Let us do this. Okay. So this is one of my favorite function in Databricks, very native to Databricks, something called display. Display is an amazing function which understand what data type that you are passing and it would give an amazing display for you. So you just do simple display, and you could see that there is something like region, revenue, and even you can see the data types are being highlighted, and even the data is present. So these give a very beautiful visual representation of any object. It helps you to understand the object better before you start doing the things. Congratulations, you have created your first data frame and did some operations on top of it. But in real world, the data frames will not come like this. The reason I gave you like this, like just I just converted a Python list to data frame, is like so that you don't have to roam around and uh, sca- roam around and for the exercises. Like you have to do multiple things, right? So to keep it simple, I have given a simple Python list which can be converted to data frame. But in real world, the data frames will be created from the data lakes, HDFS, or cloud storage. Spark supports many formats out of the box. Let us understand how can we create a data frame using a CSV. So for so that you guys understand, I have created one CSV called sales CSV, and I have stored that CSV in one of the Databricks volume. What is a Databricks volume? You must check one of the videos. It's an amazing place where we can put our data sets, and it is managed completely by Databricks. So it helps us to learn the things. So I have put one called one clean.csv, clean sales.csv there, and now I am trying to read it. So spark.read.csv is the core API. Spark, you must understand, spark.read means I'm trying to read .csv and a path of a CSV. You don't have to give anything as long as your Spark session object has access to the location. You should be able to pull that data. Optionally, since it's a CSV, we can give a header and an infer schema operation. With this much of an API configuration, we can simply get a data frame in return, which we are calling as DFCSV. And let's run this, and you'll be able to see that a data frame is getting created and data is getting displayed. Okay. As I mentioned, a lot of properties of with CSV are there, and this is just a starter property where you just give header. So if you give header equal to true, the first row of CSV it will consider as a header, and then it can infer schema as well. Moving to another important file type, which is JSON. In JSON, you need to specify the schema. There are ways to infer the schema also, but for this example, I have just created a schema because it was quite a complex JSON. Databricks has nowadays brought in something called schema of JSON method. I will maybe in advanced exercises I'll show that as well. So for now, I have defined the schema of JSON already. The schema of JSON contains like order ID, order date, customer ID, customer name. I have provided the data types as well up to the point of payment method, which is a string type. So complete schema of sales data is provided. And what I do is I'll again go to the same API spark.read. This time I'll do .json. We can provide schema where schema object is a struct type. I'm providing a struct type schema object, and there is one mode called permissive, that is keep the malformed rows. There are multiple options that are available. You can explore the docs, and I'm just right now using something called mode permissive because JSON, as you guys know, is a natural data transfer phenomenon over the network. So data come from multiple places, and there is a possibility that data might be corrupt. So, but we wanted to keep the rows. So right now I'm just putting that mode permissive, which keeps the malformed rows as well. Okay. So I'm not just like hard forming the data. And as I mentioned, one of my favorite method, I'm just displaying the data frame. So let's just run this out, and then what this function would do is it will. So I have not run the schema. Let me run the schema. And what this function does is it will read the data. It will read the file from volume. It will attach the schema and will convert it into a data frame. So we can simply display, and in display we can see that the data frame is created. Every data is being given the right data type, and till the end you can see that the data is completely displayed. So JSON is a common event logs or API data. Spark can parse nested structures. We'll cover that later when we talk about the complex types. We have a dedicated lecture where we understand how to deal with JSONs, because JSON is a very important structure. Okay, so now we have dealt with CSV and then with the JSON. Now let us understand what is Parquet. Parquet came. Parquet is an amazing data storing format. It is an advancement over CSV or JSON, where the data types are not specified. In CSV, definitely data types are not specified. In JSON, they are to some extent specified, but Parquet takes a step over it. It's like a mini database. It already has data types defined. Internally, Parquet uses some compression. This helps Spark to manage the data well. So I have created a Parquet file. I have put a Parquet file in my volume, and what I'm simply doing is I'm just reading spark.read.csv, and then I am converting that to a JSON. So this is what I'm doing because I didn't had any Parquet handy. So what I just simply did is I did like spark.read.csv. I read my sales JSON and simply converted that to Parquet so that I can use it in my own exercises. Okay. So I have done this, and the data frame is created. The data frame with that I have written, and the file is now present in salesparquet.parquet. The name is salesparquet.parquet. Now let us read this file back. Spark.read.parquet, and I am specifying the complete path. So this I have already done, so no need to run that again. So this time you can see in CSV and in JSON you have to specify format, but Parquet being an amazing um, way to store the data, they already have their data type, columns. It's a columnar format. It already has everything, and even the data is compressed. So it takes almost 1/10 of a space. So let's say you have like 20 GB of a file, a 20 GB of a CSV data. A Parquet would be around 2 to 3 GB. So that beautiful it is. Okay. So let us quickly run this and see if everything is created fine. Let us use the display function because that gives us much better way to look at it. Right. Parquet is a columnar format. It's compact, efficient, and supports schema evolution. This is the format you will most often in the production pipelines. Exploring the data frames. Once the data frame is created, first thing you will want to do is peek inside. Let us see. Let's do one thing. Let us understand what is reading the Parquet. So let's first create a JSON. Let us take our clean CSV. Now we have understood what is CSV, then what is JSON. Now let's understand what is Parquet. Parquet is an amazing way to store the Parquet is an amazing way. Parquet is an amazing way to store the data type. Um, Now you have understood CSV and JSON. Now let us understand what is Parquet. Parquet is an amazing way to store the data. It's a columnar format, and internally it is already knowing the data type and the columns. So it uses compression, and therefore the space in which the Parquet stores the data is almost 1/10 of a CSV. Now let us move to reading a CSV and then converting into a Parquet. Let us understand path must be absolute volumes. For our exercise, let us simply create one Parquet. What I'll do is I'll read my CSV and convert it into Parquet. Let us quickly convert that. We have read the CSV and we have converted into Parquet. And then let us read the Parquet from that place using an API called spark.read.parquet. Earlier we have used spark.read.csv. Then we did spark.read.json. And now to read out the Parquet, let's do spark.read.parquet. Now you must have realized this time I didn't put any schema, I didn't put any columns, uh, and also I didn't put any headers, correct? Because Parquet is like a mini database. I always call it like a mini database, which already knows what columns exist, what are the data types, and internally it uses compression to store the data. It's a columnar format, and therefore the the magic is such that a CSV data of 20 GB almost converts into 2 GB of a Parquet. So that's kind of a magic it has. So what we are going to simply do is we are going to read this Parquet, and you can see that a data frame is created. This data frame again, now this time it will have its own data type. So ID is integer, name is string, and amount is integer. So this is the beauty of Parquet. Let us explore the data frame. Once you have a data frame, the first thing you would want to do is pick inside. Spark gives you several tools similar to what you have for pandas, Python pandas. We have a lot of tools for data frame to pick into that, right? Like when you are developing an ETL, you must understand what data you have. So to do that, let us go through each step. The data frame that we have created, dfcsv, let us explore the function called show. Show simply pulls out 5 rows and display in front of you like this. Then we have something called print schema, which prints the schema of a data frame. Then we have something called columns, which helps you understand what all columns are present. So sometimes what happens is you wanted to loop in through the columns. So this gives you the capability to loop into the columns. Then you have something called the CSV count. What is the count of rows? That also we can very easily find out. And a function called describe and show, which will tell you like what all things are present within the data frame. Like it's a kind of a summary. So it will tell you like ID has 3 rows, a name has 3 rows, amount has 3 rows, what is the min max, and then common names in it. Then what is the mean value? If it's some calculated value, we can get the mean and standard deviation of this. So this helps you to get a gauge of what data you are having. Some of the quick transformation that are possible is just to showcase to you guys is like we already have a data frame, so we can run a function called dot select, and within that you can specify the columns that you wanted to show, and then simply do dot show. So it will display the data frame. You can also use, just like select, you also have a function called filter. You can use that dfcsv, and then on what column you want to filter, that you can put, and you can simply put the number. You can use the operations like greater than, less than, equal to. All the type of operations are possible. So select function you have seen filter, you have seen with column rename. With column rename is a function very extensively used, because when you are dealing with data frame, there is a way of building ETL. You have a data frame and then you keep on creating the new data frame. So when you keep on creating these new data frames, you have to start creating the derived columns. keep the word Keep the word in mind, derived columns. I'll create a separate video to explain this in detail, these derived columns you need to add to an end of your data frame, so that you get the new version of the data frame again and again. So this function with column and with column rename help you to create those new columns. So right now we are creating some column called revenue out of the column called total revenue. Maybe we wanted to do some operation out of it, so that's why we are having this. Okay, so this is how we work with the data frame. There is a CSV example. Simple, what I'm doing is reading out a CSV, spark.read.csv. I'm doing spark.read.csv, and then what I'm simply doing is I'm printing schema, filling. If there is some missing value, I'm just putting it as 0, and I'm just showing it out. So we can see I have done print schema. I am just showing it out, and if there is some missing value, I am just putting it as 0. And finally, what I am doing is a simple aggregation. The way we did a select, a filter. Similarly, we can do a group by as well. So we can do group by. Group by, you always do it by column. So we'll put like name, and then we do some aggregation operation, which is we are summing up the amount. So that information can be displayed here. Right now, I have not actually built this out as an extensive exercise for showcasing group by, so I only had unique columns. Otherwise, let's say if you have had a row, an additional row, that would have got summed up. Let's wrap up. Today we learned the foundations of data frame. They are structured, schema aware data sets like big distributed tables. You can create from Python objects or read from CSV, JSON, Parquet. Spark gives you handy tools like show, print schema, and describe. Every time you transform a data frame, Spark builds a plan. Internally, it has its own optimizers that triggers in and creates their execution plan. If RDDs were the raw clay, data frames are the shaped bricks. Tomorrow we'll learn how to actually build those bricks, applying transformation to shape your data into useful forms. That's day 6. You know how to create the data frame and explore the data frames. On day 7, what we are going to learn is transformation in Spark. Select, filter, with column in detail, how you build that out. And in the beginning of the video, I'll tell you how the ETLs are built with the data frame in mindset, because I've seen many people, many folks, what they do is they come from background of Java, .NET, or kind of Python programming, and then when they try to build ETL, they would try to build it in the same way. But building ETL mindset in a data frame way is a completely different approach. You need to think of that way. So we'll learn that. So we'll start with building the mindset of how an application or data ETLs are built with data frames, and then we'll move over slowly to understanding transformations like select, filter, with column in detail. Okay, so thank you guys for listening into this. I was very much hopeful of, rather, I was very much eager to create a data frame video, because earlier all the videos were of theory. From now onwards, the videos that are going to be there will concentrate mostly on data frames and Spark operations. So please do subscribe and listen into this. If you have any comments, please mention. Thank you. Thanks.